he's inaccessible or not reachable. It's quite the opposite. Very, very nice, down-to-earth human being. We are joined by someone who also knows him and happens to be from the same country and is in that country right now. Salut, JY.
Hi, Bart. How are you? Yeah. And I also happen to be really good friends with Sebastian because we were part of the same Y Combinator batch. So it was great to be right after him. Thank you for having me, Bart, and Data on Kubernetes. Should I get started right away?
All right. Yep, go for it.
Cool. Thank you all for joining. So this talk is going to be about Spark on Kubernetes because that's what we do at Data Mechanics, and particularly we're going to be focusing on performance tuning. So how to get the best performance out of Spark on Kubernetes. Who am I? Yeah, the co-founder of Data Mechanics, a software engineer at heart. Prior to Data Mechanics, I was a software engineer at Databricks. I was leading their Spark infrastructure team, and now we've been working on Data Mechanics for the past 3 years. Here's a photo of our team. Indeed, we're based in France. We're also hiring people in the US, so check our website wherever you are. Maybe there's an open position for you. Maybe just a quick background about our company before I talk more about performance tuning. Our goal is to make Apache Spark 10x more developer-friendly and cost-effective. And we think that the ability to deploy Spark on Kubernetes, which wasn't possible until recently, makes that dream possible, making Spark 10x better. So that's what we do. We deploy Apache Spark inside our customer's cloud account, whether it's Amazon, GCP, or Azure. And we make Spark on Kubernetes really easy, really optimized, and so on. But this talk is not about our company. It's about an open source tool we developed that does observability specific to Spark. So again, that's it relates to the previous talk about observability for Kubernetes. So we call it Delight because we want this tool to give you a delightful developer experience when using Spark. What does Delight do? It has memory and CPU metrics. And these memory and CPU metrics are visible on the same timeline as your Spark phases, your Spark jobs, your Spark stages. And the goal with that is to make it obvious when you have some performance issues and then help you narrow down, this is the part of my code that's responsible for the bad performance. On top of that, Delight also serves a Spark history server. So basically the Spark UI. So it's a great complement to the Spark UI, and it's easy to set up. So we started with Delight about a little less than a year ago with a blog post where we showed our design prototype. We got many people signed up, many great feedback, so we started working on it. In November, we released an MVP, which didn't have any new screen or new metrics. It was just serving the Spark UI, but already just that, I think, was quite valuable for Spark on Kubernetes users because you don't need to run the history server yourself. In February of this year, we released Delight internally to our customers at Data Mechanics. And then as of last month, we did the public release of Delight. So anyone can use Delight, whether you're using Spark open source or commercial in the cloud or on-premise. It works anywhere. So maybe to explain, how it works very quickly, there are two parts. There is an open source agent which runs inside your Spark application, inside your Spark infrastructure. And then this agent will stream metrics to the Data Mechanics backend. These metrics are streamed in real time. The data we're sending is not the sensitive data like the data that Spark works with. It's really metadata about your Spark applications, like how much data did I read, how much data did I write, how much memory did I use, how many CPUs am I using, and so on. And then we collect this data and we make it available on a web dashboard, delight.datamechanics.co, and these logs get automatically deleted after 30 days. So this is what a dashboard looks like. So when you log in, you can see a list of all the applications you ran recently. You can filter by user, you can filter by completed or failed. Note that right now, we only display an application completed. It doesn't get live for running applications. This is something we want to do in the future. So there are a few statistics that already could be interesting, like, when did I start it? How long did it, for how long did it run? these metrics about Spark tasks and CPU, they're pretty useful if you're interested in tracking your costs. The I/O column shows you how much data your application read and wrote. And then the efficiency is a good indicator of whether your app is well parallelized, whether it's well optimized or not. So maybe to explain, just go a little deeper, explain what the efficiency is. Basically, the CPU column explains how many, what is the container uptime that you have. So if you have, 2 executors with three CPUs each, that's 6 CPU in total. And if they run for 1 hour, then you get 6 hours of CPU uptime. So this column is typically proportional to your cloud costs. And then the Spark task duration is the sum of the duration of all the Spark tasks in your application. So one CPU can run one Spark task at a time. So if your application is very well parallelized, then these two numbers, they kind of match. That's what we see here on the second line. We see that we had 40 hours of CPU on time and 35 hours of Spark tasks. So most of the time, your CPU were effectively running Spark tasks. In fact, this ratio is the efficiency ratio. On the other hand, on the first line here, this notebook analysis, we had 10 hours of CPU uptime and 1 hour 45 of Spark tasks. So there's a big discrepancy between the two. This indicates a low efficiency. What could be the cause for a low efficiency? Well, we'll see it in Delight on the next screen, but it could be that you set up Spark to have a fixed number of executors, and that after some time, some executors were not removed, even though your application was idle. So that's a common cause of inefficiency. When you use Spark in an interactive way, it's best to enable dynamic allocation. All right, now let's go through concrete examples of applications we tuned with Delight, with our examples taken from our customers. So I will go through basically 3 examples. The first one is a parallelism issue. So it's a case where the efficiency wasn't that great, and show you how we can improve it. This example is taken from Weather 2020, which is a weather analytics platform. So let's dig into that. So I'm going to open up the Delight screen for this application. And so I think hopefully just from this screen, it can be obvious that something is wrong. When we look at the overall usage breakdown, we can see that for about half of the time, some core was idle. And the efficiency score was 42%. So when we actually focus on this graph, which shows you CPU usage over time, we can see that there's a big area here in gray where a lot of the cores were idle. 93% of the cores were idle. So this is probably where, for some reason, we didn't have good enough parallelism. Only a very small percentage of the CPU were doing work. And so here we can basically match this with the job and stage that we're running. So it was job 1, stage 1 that was running. And if I click here, it's automatically going to take me to the Spark UI. And one interesting thing I can see here is that for this stage, there were only 2 tasks running. Even though we had, let's go back, we had something like 16 or 17 cores available for the entire cluster. So 2 tasks out of 16. That's why we didn't get good enough parallelism. One CPU core can run 1 task at a time. So if you want to take advantage of 16 cores, we need to have at least 16 tasks. And typically, we recommend having 3x the number of tasks. So 48 tasks would be best. So how do we change this? Well, that's where you need to go back to your code. It can be an issue with the input data. So maybe there isn't enough partitions in the input data. It can be a Spark configuration that you need to change. So there's a config that lets you tune the default number of partition that is used, these kind of things. So Delight doesn't yet automatically fix the code for you, but hopefully it gives you the feedback you need to tune the application. So moving on to another example, let's talk about shuffle. So shuffle in Spark are the phases where you send data across your entire cluster. So the Spark executors, they exchange data among themselves. So we're going to look at an application from Jellyfish, and before we did some optimization, this is what it looked like. You can see that a big portion of the compute resources were spent doing shuffle. In particular, two stages were really shuffle heavy. So how does the shuffle work in Spark? Well, first, the executor writes the data to disk, and then this data is going to be pulled over the network by another executor. And what we see very often, a common mistake we do in Spark on Kubernetes is we don't mount the disks in the right way. So to get the best performance out of shuffle-heavy queries, it's important to use local SSDs, because these disks have high bandwidth, high throughput, and so they can increase the performance of shuffle a great deal. So this application ran in 2 hours 12, and 60% of the resources were spent in shuffle. And now let's go back and look at the performance of this app after we attached local SSDs. It ran in 26 minutes, so I think it's maybe maybe 4 or 5 times better. And yeah, shuffle is almost gone. This is the shuffle percentage, 0.6%. And there were no code change here. It was just about mounting local SSDs that the Spark executors can use. If you want later in the Slack or on YouTube, I'll send you a link to know how you can do that. But I think what's most important is that before Delight, it was not obvious, from the Spark UI. Honestly, unless you're have a lot of expertise, it is not obvious that you're spending your time in shuffle, and Delight makes it hopefully obvious. Yeah, maybe let me not wait for the Spark UI. That's another thing that sucks with the Spark History Server, is that when your logs are big, it can take, I don't know, a few minutes to load, and Delight always loads instantly because we do the work ahead of time. It's actually loading, yeah. But so here, it was really not obvious if you just look at the Spark UI to tell that this application was suffering from slow shuffle. Moving to a last example about memory troubleshooting. Actually, 2 examples, one with R memory and one with Python memory. But my goal here is that to show you that Delight also has statistics about memory usage. So if we scroll down, we can actually see the top memory, the peak memory usage for the executors. And so this is where you can tell that maybe some executor used almost all its memory. It's not good to be close to 100%. If you're close to 100%, you risk getting an out-of-memory kill, where typically Kubernetes will realize that you're getting close to your memory limit, and it will just kill your container. So the JVM memory is typically easy to control because you set a max heap, but the memory used by other processes like R is hard. It's not, you can't control it, and you can't even track it. So Delight now gives you this visibility, and now you know that you've been using 17% of your container memory for R. Maybe one last example about Python, because that's the most common language for Spark. Well, you can also see the breakdown between JVM, Python, and more. So there'll be more work coming. Right now it's just this screen, but we're going to have a new page for each executor where you can track memory over time. This should be coming out, I don't know, maybe in a month. So we're pretty excited about that. I think we're pretty much it. I think we're doing fine on timing. So what I love for you is, to try it out, to let us know your feedback. As I mentioned, Delight is free, entirely free, and it will remain free. You just create an account on delight.datamechanics.co. Then you head out to our GitHub page. And you follow the installation instructions specific to your platform. It works on top of Databricks, EMR, Dataproc, Spark on Kubernetes, Spark on Yarn, Spark Submit, Livy, whatever kind of infrastructure you used, we have instructions for you. And then once you went through them, your applications will start showing up. Thank you for having me. Not sure if we have time for questions.
Unfortunately, we don't. But what we're going to do is that if you can put the links in the YouTube chat so that folks can have access to those. And then also we did get a question that I'm going to put directly in Slack so you can respond to it there.
Okay. Sounds great.
Always a pleasure.
Thank you so much, Bart.
Have a good one.
Have a good day.
Bye-bye. All right. Good. Moving.